Hello and welcome to another free code session. My name is Jason Bach, and that's the answer in front of you. It took a little bit of time to figure this out. I actually went to the Discord channel for Rosalind and asked, and somebody from Microsoft, didn't give me the answer, but kind of gave me, I won't say a hint, like they necessarily thought it was the way to work, because that person's kind of said, well, this is probably what you're going to have to do. And I kind of had the hunch that it had to do something with looking at your base type, and it had to do with the constraint being, or the generic value being set, and on and on. So I got to something that I was able to test. It works. It doesn't break any other tests. And when I ran code generation, it came up with one exception, but I was able to fix that. So basically, when I do, where's my mouse? There it is. When I do this get constraints, there was a thing in here to say has not null. I just expanded it into a extension method that says, okay, well, if it has not null, you need it. Now you have to do something more complicated. You have to look at the type parameters original definition. Is that containing type and interface? And then what you do is you try to find all of the type parameter constraints on that original one, go back to the containing type that has your type parameter on the type that's given to you, find the type parameter by name, and if that's not null, then go here, get the index, and look to see if it's basically not annotated. If all that's true, you return true. That needs where whatever that is not null. So that fixes it. So yay. It took some time to get there, and like everything, it could be a problem, but I was actually able to include now AutoMapper, because that was one of the things that was messing with AutoMapper. So we got that done. So I'm going to move on to another one and see if we can figure that out. Or I might get to a point where I'm like, oh yeah, I need to research deeper and then we'll figure it out. What I might do in that case is add on to this video at the end and say, okay, here's the resolution, and not leave it till the next one. So let's come over here. This one's closed. We're going to try this one. So this is something from silk.net that I found it on a IVK surface because of reasons. There's an interface that's defined something like this. Let me zoom in a little bit there like that. And you can see that you have something that's defined as unmanaged, and it's also a type parameter. And when the generator does something, it gets all messed up. Okay, so I have some things in here what I think the problem is, but we're going to kind of just take this slowly and say, let's figure this out. So let me create a test class with this type in there. We don't have anything in here yet that has anything to do with pointers and generics. So although I do think no, I don't even have a generic thing in here, because of course not. Why would I ever have that? Again, I've said this many times, my generator tests are all over the place in terms of what I put in there. So I'll make a branch, I'll make a test, make sure it fails, and then I will come back and we'll start diving in to see how in the world do we fix this. Okay, well, I've got it here and it fails, but it fails in a way I didn't expect, because it fails a lot more. So I get 8 errors. I don't get one that you see here, the CS0208. That one doesn't even show up. So I'm kind of a little stunned. I mean, obviously, whatever Rox is doing, it ain't right. So got to scratch my head on that one. One thing I should, do we do that? The thing I'm wondering is, do we have unsafe code? We must, right? Because this isn't the first time we've said unsafe code in a, well, okay, so that's pointer arc type builder tests. This is extensions, which we don't like, generators. Okay, so we do have Well, we must because we have pointers here. But that doesn't mean that, well, we have an unsafe interface here. So do we do anything on this one to say, by the way, make sure you're doing unsafe stuff? Doesn't seem to care. And this one passes. So, okay, whatever. Let's go on the assumption that we're actually okay with being able to build where we say it can be unsafe. I thought you had to set that explicitly. That's why I'm a little unsure about this, but so yeah, this is from, oh, wait a minute. Is this ours? Oh, is that where it's from? Do we do something in here that says compilation art options, warnings, parse, warnings are nullable? But do we do anything in here for unsafe? No, we don't. So I'm a little confused as to how this is actually coming through. And we're saying language version preview. I'm not sure that we really need to do. Does this need to be preview anymore? Question. Anyway, whatever. Let's take this and do our little trick that we always do. We'll do it up here, actually. Okay. And what doesn't I like about this? Unsafe may only appear if compiling with unsafe. Because, of course, allow unsafe code. Allow unsafe blocks. True. I think that's what you need. Yep, and it goes away. Okay. So now let's do public class surface, which implements iSurface. Okay. And let's implement it. Now, does that implementation do anything wrong? It doesn't. So this isn't a case where what Visual Studio gives us also had, like we just saw at the last one, gives an issue that we don't know how to solve. Okay. Now, I don't, yeah, if I remember right, the problems aren't with the generated code. Like if I come down here and I look at the thing that says, let's pull that down. Okay. Now let's come back up here. And so you can see we do public unsafe void create t pointer allocator where t managed. And so we get that correctly. And so I think that's actually okay. If I look at the errors again, they're all like on 8. So what's 8? Remember, I think it's 1, 2, 3, 4, 5, 6, 7. Okay, 8. Oh. Yeah, and I think I hint about this in the error message. That the projected type, project argument doesn't expose a t generic parameter as a shuffle argument for t pointer. That would trickle through. Well, that's fine because you should be able to say here of t, where t is unmanaged. Like that's okay. So I'm not sure why that would be a problem. If I came up here, you'd think that would be okay, right? Yeah. So I'm not sure why that's an issue. So let's do this. Let's grab that. Actually, no, let's do this. Let's grab all this because we need all the things to align. So we did that. Let's grab all this. Page up. Grab all this. Why? Why would you do that? Page up. Okay. So now let's look at the errors. So they're saying a line 8. So what's line 8? Top level statements must precede namespace and type declarations. What? Speak that again? What? It doesn't make any sense. Program using top level statements must be an executable. Oh, wait a minute. Am I looking at the wrong thing? I think I might be looking at the wrong thing. God. Should keep that slap in there. I'm a moron. And you can, you can keep that in there because that's probably a good thing to do. There. So now we just say this and this. God. Okay. Run it again and let's see what happens. Okay, as I expected, this time, we don't get any diffs and code errors. We get 6 errors. So we're not, we're not getting what we had before. So it's a little better. And then now this follows the 10 and this. Okay, so we're at line 10. Where's line 10? Yes, so the argument evaluation for T pointer. It doesn't know what T is. So, and that's the problem, that this actually needs to all over the place say that when we do an argument evaluation for, we can't just have T there, because if what we're trying to do is based on a generic, that actually has to be generic as well. So let's look for that. Let's close these off because we don't need these anymore. Okay. Let's come up here and let's look for that. So this is being done here. And this is on a type reference model. That's the only place we have that text anywhere. So this has got to be it. Okay. So the type that this is coming in for, we're going to flatten it. We're going to say T pointer. And then this, like that's the name. Is it the responsibility here to actually be the one that arg for type? Get projected evaluation delegate, fully qualified name. Type model namespace, projections for namespace. That is, projections for iSurface dot projections for namespace. That's the name of it, but that's not what we're looking for. What we're looking for is, I think this. So validation delegate name here. Yes, so we say internal unsafe delegate, and then we do a class right with it. Okay, so we're getting close. So this gives us the delegate name. And then we put what we need here is the parameter name from where this came from. So yeah. So we got that going for us. So let's do this. A lot of this is just figuring out what in the world did I do before. Oh, I think I'm in release mode. Sorry. All right. Well, we got here. And it's because we noticed we needed a projected type. So the type, it knows it's a name of T. It's flat named as T pointer. And it's T pointer, yeah. So we know that's all there. But what we don't know, we know it's a pointer. But why were we called? It's because it's an esoteric type. And we get esoteric types from the type mock model. So we call build with the type mock model. Okay, and so we go into here, and then that does that. And so we got esoteric types because we go through all the methods and we go through all the properties, and we look through all the parameters and say if it's a type. And so we just say, here's a type. Okay. But we didn't capture here if it's a method parameter and it is esoteric, but we don't capture whether it's a type parameter itself or not. And that's a problem. So we need, if you notice this type reference model here, just seeing it as T, you don't know what that is. You can't determine from that point if this type that's given to you is a reference type, is a pointer, record is ref-like is reference type. But what we don't know is it a type parameter? Because if we look at a type reference model here, we get a type symbol, right? And so if we look at the type symbol, type is there like parameter here? No, we don't know that. So just having a type is just a type. There's no way to say, is it, well, could we say just type is I, type as I named type symbol dot parameter. Well, that will say what its types parameters are. We don't want that because it's saying that's a type. So this is the problem. We're going to have some way to say here is this type that you've given me, which is just T, is it a actual type? So let's do that. Let's just play around with this. Okay. And then at some point I'm going to say, okay, stop. Because I think I'm getting close to what the problem is. At least with one of these. And again, it makes sense. It's like T star. T, what's T? I have no idea what T is. And then I'm probably going to also need to put in whether it's unmanaged or not. Because like if I look down at this code here, you say where T is unmanaged, that's also going to need the same thing. So, okay, so type, this is a nice surface, don't care about that. That's another nice surface, don't care about that. Here's the T pointer. Okay, so, yeah, we know you're not annotated, that's great. His namespace is type. I honestly don't think anything here is going to be basically saying this is a, does its original definition, I think would also just be a, like a type itself. It doesn't really help. Is anonymous type, ref-like, reference type, unmanaged. Yeah, we know it's unmanaged. Original definition, special type, type kind, underline namespace, lazily pointed. Yeah, so what we need here is from the parameter. So the parameter actually, I bet, if we look at the parameter, does it tell us anything on this to say, well, it's a parameter, yeah, but where is the parameter's type? Is it a reference to a, like a, so we got here, so we're on the method itself. Okay. And the parameter model here, you pass in the parameters. And the parameters just have types. But what we're not doing is specifying, yeah, we're not specifying enough. Because by the time we get to this, we don't know if the type for that is based on a type parameter. Is it not? Like, where did the type actually come and get defined? We don't know. Because with our model, we don't keep that around. So I think this is where I'm going to stop. And then I will end this video with an edit and just say, okay, this is what I did, because I got the feeling this is going to take some work, but at least I've hunted down now what I think the problem is. And of course, when I do this, putting in that here is going to start making this also be a generic. And that's going to have to trickle through. So this starts getting very involved. But we saw here that when we do this, this is all in one shot. Right. We do all this in one shot. So if we need this to be a generic and a constraint, then we can hopefully figure that out here and put that in here. And then I think there might be one other problem that, like we say 35, what's line 35? Yeah, I bet it's going to say, I don't know what T is. Yeah, it doesn't know what that is. And then 87, if I go to line 87, God, 87. Argument for T pointer. Yeah, it doesn't understand here. I cannot convert from T pointer to, yeah, some T pointer that I have really no idea what that is. I'm not exactly sure what the cast problem is here, because argument for T pointer is up here, and that's just a class. But method handler expectations. Oh, yeah. Because, okay, that's right. Because what we're doing up here is we're going to call this valid. This is a pointer, which we're saying is T, but it doesn't know what T is. If we can just put T there, and then also here, like we'd have to put T on all those, then, yeah, that's the problem. Okay, so I think I've got my head around where the issues are. So now I'll just do them, and then I'll add on at the end what I did to fix this. Okay, I figured it out. And it took more than a day because I know the shirt's different. So it took some time, but the main problem was that I needed to figure out if a type reference on a parameter from a method is based on, well, wait, how did I say that? The type of a parameter from a method, if the type is based on a type parameter, and then also if it's a pointer type, then those matter. So the way this ended up working is on the method model, when we create the parameters, we now look at the target and we determine the type. And then we're going to say, is it based on the type parameter? We just have to be careful if it's a pointer type. If we know it's a pointer, then it's either a pointer type or a function pointer type. And so we do the cast, we get the base pointed at type. Otherwise, it's just a type. And then we look through the methods type parameters, or the containing type parameters. Yes, I did do that right. Okay. And so then we pass that flag in here. The parameter model will take that flag and it will say type reference model. Now we make this optional. And the parameter model, now that I'm looking at it, we will always do this because the only time that this is created, I take that back. Oh, that's right. It's on the constructor and also the property. Would we care about this on the property? Maybe, possibly, but I'm fading. It's July 4th, and I did a bike ride this morning, and it was fun. It went well, but you know, whenever I do these bike rides are a little bit longer than what I usually do, I need to take a nap, and I can tell the energy's fading. So this may need to be done on the parameter as well, but we definitely don't care about it on the constructor, because there are no type parameters with constructors. Actually, with properties, we wouldn't, because indexers don't have type parameters. So never mind. Okay, so sometimes it's optional. That gets passed to type reference model. That's also optional. And here, I think we use that to say, well, if you're esoteric and you're based on and you are a pointer, then we get the argument parameter type. And we use that in pointer arg type builder. I think I can speak. And we use that in places like here, if we need to make a type parameter with the generics, and also down here. And then we generate the code with the right stuff. And then this is also used in other places, like in method builders, where it'll automatically pick these things up. So it all just works, test, pass. And this was originally coming from a type in this library called silk.net. I had to update one mapping here, but now that actually works. So if I go to the program here, you'll see down the list, that in the list of types we include, that now also includes silk. So that's cool. We've finished one off. I haven't committed that yet, but I'm going to do that now after I finish this video up. And I'm not sure what I'm going to do next. Let's see here. This is that. If we go to issues, I'm not really sure what I'm going to pick next, but it will probably be some more bugs on the list here. I want to knock off as many bugs as I can in this 7.1.1 release before I move on to anything with 8.0. So it looks like we've got 5 left. So yeah, we'll see what I work on next in the next video. Thank you all for watching. Leave comments and questions below. See you in the next episode.